Welcome to this advanced Python course. So in this video, we are going to talk about decorators, generators and iterators, Lambda functions in Python, classes in Python, exception handling in Python, file handling in Python, object-oriented concepts, and asynchronous programming in Python. This is a continuation of my Python for beginners course, which I've uploaded on this channel. You need to check, the link is in the description below, and you need to take that course before, if you don't have any experience in Python, so that you can get the fundamental concepts of Python before taking this advanced course. Beginners course is going to cover fundamentals like setting up of the Python environment, variable declaration, functions, loops, and some sort of things. So please subscribe to this channel and make sure you like and share the videos so that you get notifications whenever I upload new videos on this channel. In the previous video, we talked about functions, more generic functions like the def add function x and y and return x plus y. And if we call this function the add function and pass the parameters, let's say print, and pass the parameters 2 and 3, if we execute, you are going to get 5 in the console. So these were more straight the point functions which we were working with previously in the last lectures, but we also moved on to use the function that uses the positional arguments, like using the args, and we were returning some of arguments here, and then next we were printing this, like with multiple parameters. We can also demonstrate by printing the add function with different number of parameters, like 1, 2, 3. If we run or execute this, we are going to get two different outputs, but we have defined a single function which is going only to take positional parameters or positional arguments as a tuple. So you can see that these are just a tuple. Why? Because we are going to use the tuple with different number of parameters inside the function call. Nextly, we are going to talk about positional arguments using the keyword arguments, which passes a dictionary. It's a bit different from this. All the functions which we were working with previously were working directly with a tuple, and we are going to introduce a different type of function that works with a dictionary, right? So we are going to define a function and just call it display here, and it is going to take the keyword arguments, use two multiplication signs or two stars here, and we simply want to print keyword arguments and return nothing here. So we are going to call this function the display function with positional arguments like a is assigned to 1, b is assigned to 9, c is assigned to 10, something like this. So what we are going to do, we are going to execute this and have a look in the console. You can see we have got the output of a dictionary in our console here. So this a is 1, b is 9, and c is 10, but it's in a dictionary format. So this is how you can work with keyword arguments in functions and in Python as parameters, right? So next we are going to talk about what are decorators in Python. So what is a decorator? A decorator is simply a function that is used to modify the behavior of a defined function. For instance, if we want to modify the function declared like this, you can actually use a decorator. So decorators are much more used in authentication and access control, where one needs to give access to certain pages, like in a system, certain pages. A system might be an e-commerce website that has admin privileges and a customer privileges. A customer is allowed to access all other pages except the addition of categories, prices, and products. But the admin is open to add those categories and products because he is the admin, or he has got the admin role or admin privileges. And we can also use the decorators in logging, right? Like we want to log a certain message when executing a block of code, you can simply call that decorator. We can also use it to actually see or calculate the running time of a function, right? The time of execution of a certain code or piece of code. So we're going to demonstrate all those three in this video. We start with a logging function, right? So let's remove this piece of code and define our function, and we call it logging function. And it is going to take a function as a parameter here, and we are going to define a wrapper for this function. And this wrapper is going to take the arguments and keyword arguments. This is just in case if you want to pass some arguments, but in this case, we are not going to use these args and keyword arguments. What we are going to do is we are simply going to print before the logic, or before the business logic execution here. Excuse me for the typos. And what we are going to do is to call the function exactly with whatever the parameters it have. And here we are going to print after the business logic execution. What we are going to do is to return here. And here we are returning a wrapper. This return means we just finished executing and we don't want to go to the next line. What we want to do is just to skip the rest of the code below. Right, so this is the purpose of this break. If it's in loops, it is what we call a break statement, right? So we are going to move on to declare our function now. We are going to use this as a decorator. So to use this as a decorator, you need to use a sign and the name of that particular function, which is this outer function here. You can see we have put it as a logging function. We are inheriting the behavior of this function into the next function. And what we are going to do is we are going to define another function, and we call it some function here that does whatever it does. What we want to do is to print that we are inside the business logic. As you can see, we are inside the business logic function. So the last thing to do is to call this function. So we can call some function here. And if we execute, we expect to see the logs in our console. So you can see the first thing, it executed what is in this wrapper function, which means whatever written inside this is inherited and become part of this child function. As you can see, we have before the business logic execution, and now we are executing inside this business logic function. This is the next statement executed after executing this. And after that, we executed the last statement in our wrapper function or in our decorator. So this means that the behavior of this function below was modified by the function above. So this is what a decorator does. So we have actually demonstrated how logging works. Okay. Next, I'm going to show you how you can see and implement the time logging. So let me define a new function here and call it time logging. And in this, we are going to accept also a function, and we are going to define a wrapper function here that takes keyword arguments, and we can have start time as time.time, and we are going to import this time because we are going to use it in this function or in this demonstration. And what we are going to do is we are going to call the result of the function, the actual function execution, which we want to modify the behavior of. And after that, we are going to, let's say for instance, let's also import the date and time here. Import date, or let's say from date time import date time, something like this, right? And after start time, we want to print the date time that now. Okay. And after here, what we are going to do, after calling the function, we want to also print the time we completed the execution of the function, right? And what we are going to do is to have the end time here. And we are going to print also the time taken to execute this function here. After that, we are going to return the result in this function. And after returning, we are going to return the wrapper function here. So this is our time logging function, how it looks like. It is going to modify the behavior of a function which you are going to define, and it is going to be executed at this particular time, right? So let's go ahead and define our time test function. We are going to use a decorator of time logging, and what we are going to do is to define the function. Let's say time test here, and what we are going to do is print something here. We are inside the business logic function, here. Okay, and after that you can just go ahead and call this time test function, and we want to execute it. You can see the time is 22:07 and it's still finished at 22:07. You can't actually see what's going on, so what I'm going to do is to throw some sleepy time here. I can say time.sleep inside this function, and we'll give it let's say 6 seconds, and execute this. You can see we have this first log, and wait for 5 seconds, and we have the rest of our logs, right? So the first time is 09:22 29 seconds, and here we can see 09:22 and 35 seconds, but the time to execute is 6 seconds. So you can actually calculate from 29 to 35, there are 6 seconds there. Okay, so this is how you can implement time logging. Once more, you can simply call a function. So we are calling a child function inside our wrapper function or time logging function or our decorator. But this function, we don't know what it does yet. You can fit any type of a function here that does anything you want. And the times, the codes inside that child function or the function which is going to use this decorator, the time which it is going to take to execute is going to be considered in the time of execution here. So this is all you need to know about time logging in Python, right? The last time I want to talk about these decorator functions is in access control. Let's say you have an e-commerce site where you want the admin only to be able to add categories and products and change the prices of the products in an e-commerce system. And you want the customer to do the rest, like shopping, adding products to cart, etc. So what we are going to do is we are going to define a function that is going to restrict access to only admin. Okay, so let's say def admin only. That is going to take a function as a parameter, and we are also going to define a wrapper here. The wrapper function takes the argument of a row, keyword arguments, and arguments, right? And we are going to test if the row is not an admin. What do you want to do? Simply print access denied, something like this, because someone is not an admin, and return, which means we want to break the execution of our function. Or otherwise, if the row passed is an admin, want to return the actual function with the row and keyword arguments and arguments, right? So this is what we will need to do, and later want to return the wrapper function here. Okay, spelling of return is misspelled here. And then this decorator is complete now. So we are going to define another function and use this decorator of admin only, and this, let's say, categories. And we want to put a row here. What we are going to do is print inside the category business logic of a system, right? And what we want to do is to break this execution after. So the next thing, we are going to call our category function, and we are going to pass the row of user first, excuse me, and let's execute this. You can actually see that access denied. Why? Because the row passed here is not an admin, but it's a user. So let's go ahead and pass the admin here and execute. You can see that we are inside the category business logic. What it is doing is it is going to restrict the access, which means if you take this in an e-commerce site and put it on top of each and every function that you want a user to have the privilege of an admin, for him to be able to access that particular function or the logic in that function, you can simply do this and put the decorator on top of that function. And you can make this function more advanced, and so that it extracts the user role from the actual database, and it is going to use that role to actually determine the level of access or the privileges of that particular user. Functions have introduced us to where we want to learn about global and local variables. So what is a global variable? Let me remove this. A global variable is just a variable that is going to be accessed throughout the course, the whole file, a Python file or Python module or a Python class. It is going to be declared maybe globally in a class or in a file or a module. So let's take, for example, want to declare our variable x as 10 here. This is a global variable, and we are going to declare a function, and we are going to say this function is n function. It's just a name, and we are going to, let me first pass no parameters in here, and I'm going to declare another x and initialize it with 7 inside here. What I'm going to do is I'm going to print this x and say inside a function, and after saying inside the function, I want to print the value of x. After that, what I'm going to do is I'm going to call this function n function, and after calling this, I'm also going to print outside the function and put x here. So if we execute this, I'm going to get two different values even if we declared two x's in our code. Right? You can see we have declared x on this first line, and we have declared x inside this function. You can see the space behind the indentation, and you can see that this x or this block of code belongs to a function, n function, right? So what it means is this variable is not accessible outside this function. The scope of this variable is going to end inside this function. So this is going to carry on from this function at this point, and we are going to get the value of 10 here. Let's test this by removing this x from this line, the first line, and try to execute this code. You can see that name x is not defined. It is complaining that this x here, you can see it is highlighted on line 7 here. This x is not defined because it's globally unavailable, and this line can't access the code inside this function even if the function is called here. Okay, so this is what we call a global variable, and we are going to remove this. We are going to undo this and add back our x is equal to 10. Okay, so let's try to remove this inside function declaration and try to execute this. You can see that this x is assigned to 10 is also accessible inside a function, but a variable declared inside the function cannot be accessed outside the function. So this is what we call a variable scope. I can undo also here. There's another way to declare a variable that is local to this function. I can put it inside this parentheses, which means this is now a parameter. This means this variable is also accessible only to this function. Okay, like you can see, if I try to modify, or if I say x is equal to 9, as you can see, what are we going to do if we execute this code? Okay, missing required positioner, or I'm calling this without a value. So I can actually not pass direct a value inside here, and I can pass a value inside the function call here and put 9, something like this. Let's execute this code. You can see the value of 9 at this point is 9, and this is limiting 9 only to the scope of this variable. Okay, and to the scope of this function. So this is what we call a global or local variable. So this is a local variable and this is a global variable. I've introduced this topic because we want to look at classes in the next lectures. So you should be aware of these global and local variable declarations. Next, we are going to talk about Lambda functions. Lambda functions in Python are anonymous functions defined using Lambda keyword, and they are used for one-time operation in most cases. So the definition of a Lambda function goes like, let's remove this. It's not going to be defined as a regular function which we were working with previously, but we are going to follow a different approach. So it's Lambda, then we put arguments here. Sorry for the typos, arguments, and then expression. So this is how one can define a Lambda function. Okay, so for instance, we want to define a function to square a number or to raise a number to the power 2, or to raise a number or to square a number, right? So we are going to define a Lambda expression and say square is the variable which we are going to put the Lambda, and we put the Lambda here. And what are the arguments? X. And what we want to do is x raised to the power of 2, or x squared, right? So what we are going to do is we are going to call this function and we raise the square to 5. So let's execute this. You can see we are getting 25. So this is the Lambda to raise a value or n variable to the power of 2, right? So if we change, we put 4, we're going to get 16. We put 7, we're going to get 49. So this is how you can actually raise to the power of something. So for instance, let's say we want also to, I've done with this example, let's say we want to add numbers. We can say sum here is equal to lambda, and we put x and y here. Then what do we want to do is to say x plus y. Okay, so what are we doing is we are adding two numbers, so we can print to the console sum of 1 and 2, we get 3, right? So this is how you can actually work with a lambda. So these are the simple lambdas which you can work on. Working with lambda on a list, so we are going to remove this and define a list of numbers here, 1, 2, 3, and 4, for instance. So we are going to see how the map function in the Lambda works. Okay, so what it does is it is going to apply the Lambda function to each element in this list. So for instance, let's declare our Lambda function here and say squared. We can say squared is assigned to a list. Then we want to map lambda x and raise this x to the power 2. So we are going to raise each and every element in this list to the power 2 or squared. We are going to square each and every element. So we can print squared here and execute this. You can see we are getting 4, 1, 4, 9, and 16. So before we can print numbers so that you can actually compare how each and every element was manipulated. So print numbers here, you can see we have 1, 2, 3, and 4, but here we have 1, was 1 raised, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. So this is how you can work with a lambda, and this is called a map function, right? You can see we have used a map function here. We have used a map function here. So this map function is going to be used to apply the lambda function on each and every element in a list. We are going to demonstrate how we can use the filter, right? So the filter function or the filter lambda function, the filter elements based on a condition, right? So if we want to filter the elements in this list, let's remove our map function and use the filter. And if we want to use the filter function here, what we are going to do is we are going to look for the even numbers. Okay, so we are going to say even, or even if you say odd, it's one and the same thing, list, you might want lambda filter. And what do you want to filter are all the values that if we divide by 2, they will give a remainder of 0. So this means this is an even number. So we are going to print the even here and have a look. So we have 2 and 4 only. But if we change this equal to 0 to 1, we are going to get odd numbers. So let's change this to odd also to demonstrate this. Odd. Okay. If we execute this, you are going to see we got 1 and 3. So this is how you can use the filter. It is going to be used to filter elements according to a certain condition. We are going to demonstrate how to use the reduce. The reduce is used to reduce the values to a single element. In most cases, like we want to add the numbers in this list or the numbers list. So what we are going to do is we are going to declare the sum. And what is the sum do we want to do? We want to reduce the lambda of numbers here. You can see we put x and y as our arguments, and the expression is x plus y, and we want to perform the action upon the list of numbers here. And what we are going to do is to print this sum. As you can see, we have reduced this to a single value, which is 10. So this is how the reduce works in lambda expressions. Let's demonstrate how you can use sort with lambda functions. So what I'm going to do is to remove this code, and I'm going to declare a list of students here. And this list contains a tuple inside. I give a name as Alice and the age to be 23. And the second student, let me put him as Cole, and the age is 21. Let me put, excuse me, I forgot to make it a tuple here. And let me put another tuple, a student of Chai, and the age of 78. Right. So what we are going to do is we are going to sort these students using the lambda function. So we are going to say students.sort, then we put key equal to lambda. Here we are going to put student, and we are going to sort with the student age here. So we are going to print students, right? So firstly, we are going to print these students, and we want to compare the results before sorting and after. Let's run. You can see initially we are getting this list as it is: Alice, Cole, and Chai. But after sorting, we are getting Cole, who is the least age here, Alice the second, and Chai the last. So this is how you can use a lambda to sort things or students. We are going to talk about classes. A class is a blueprint of an object in Python. So a class simply holds the data which needs to be a description or the details of a certain object. For instance, if we have a person, we know that a person have got a name, a person have got an age, sex, and some details which you can name. Okay, so if we want to have or to hold those values of a person, of each and every person, let's say we need a standard of accepting the details of a person at a certain college. We know that there are certain details which we look for: the age, the gender, the name of that person, and the grade of which or the previous qualification he has. So we are going to declare that blueprint as a class, and it is going to be declared with lower cases of characters. And let's say we need to declare a class called person. And we know that the person, we need to have the name, and maybe the name is Colin, and the age of that person is going to be 24. Okay. So what we have done is we have declared the class and directly initialized the values or hard code the values which we want to work with. But this has got a problem. We are going to correct this when we are going to do the initialization or instantiation, or the when we are going to declare a constructor in this class. So we are going to try to create an instance of this class, and then we want to print the name of a person in this class, right? You can see we are getting the name of the person we have declared in this class. But the problem with this is that we have hard-coded the values, and this class can't hold the details of different people. It only holds the values of a single person, right? So what we are going to do, we are going to remove this. So to enable this class to be able to hold details of, or data of different persons, we are going to declare a function that is going to take care of the initialization or instantiation of these variables, name and the age of this class, right? So what we are going to do is self.name is equal to name and self.age is equal to age. Why did we declare this method or this function? It's because if we declare a name directly, not initialize it, and the age and not initialize it, it is going to throw some problems in here, because a variable needs to be declared and initialized on the same line in Python, since it's dynamically typed, right? So after having this, we have initialized this object, and if we want to keep the details of different people, what we are going to do is we are going to create different instances of this class. For instance, we have 3 people in a queue. We want to capture their names and their ages. What we are going to do is we are just simply going to create new instances of this class and initialize the values. And we have person 2. Instead of John, let's change the name or the parameters here to Peter, and the age is 32. And next we are going to declare another instance for our person number 3. I'm going to say person 3 is assigned to person, and this person is going to be initialized with the name Jake, and the age is simply 34. So what we've done is we have used this same blueprint to capture the details of 3 different persons, right? But previously, we have seen that there was no way to actually capture the details of multiple persons. But here we can print the value of person 1.name, person 2.name, person 2.age, and person 3.name. Let's do something like this. We have John 25, Peter 32, and Jack, right? Why? Because we've printed the name of person 1 and the age in the same line, with the person 2 name in the same line, and with the person 3 name in the same line here. This is why you see something like this. So this is how you can declare a class and instantiate it. So you can also have the methods in this class that is going to work upon the data that is provided. So let's remove this and define another method that is going to work with this data. Let's say define a function called greeting inside here and put a self here. And we have let's say self. And what we are going to do is to say print good morning or good afternoon. And what we are going to do, let's format this to a string. So to format this, use f here and use this and say the self.name. What we have done is we have put the name inside the quotes as a string and format it to actually say this is actually a variable inside these curly braces. So after that, what we are going to do is we are going to create an instance of this class, and we have person assigned to person class. And after assigning this person class, we can say John, and the age is 56. So what we are going to do to call this function, we are going to use the instance, the person, and we know that we can access everything under this class. So a person dot greeting, we are greeting this person, which we have initialized here or instantiated here. So we are going to run this, and you can see good morning, John. So you can declare as many methods as you want inside the class. We are going to talk about iterators in Python, right? So previously we implemented for loops where we say for I in range, let's say of 5, and print I. So we're saying if you execute this, you are going to see 0, 1, 2, 3, 4. Okay, so this is just an iteration through a range of objects. When we just mention one value like 5 inside here, what we are saying is we are telling this to iterate from 0 to 5. So can you imagine we have a large number in here, like 1 million. If we have this large data set, what we are going to do is memory is going to be more used when we try to run this for loop. Why? Because it is going to keep all the values from 0 until to 1 million. Okay, so this is going to be a problem when we try to manage our memory. So this can introduce us to iterators. Okay, so iterators are just objects that implements the iter and the next functions, so that it only keeps the track of the current value which wants to be worked on, and it is that value only that is going to be stored in the memory. Okay, so let's write the code here. As we illustrated by 5 here, you have seen that we have printed all the values from 0 to 4, and we have printed 5 values in here, which means all 5 values were loaded into the memory. So we want to avoid this when we work with large data sets. because it will end up in memory constraints of our machines. So what we are going to do, or we are going to declare an iterator here. So an iterator is just a class. Let's call it counter here. And what we are going to do is we are going to declare or this init method and have a start in here and end. After having this, what we are going to do is to say self dot, instead of having start, we can put the current in here and the end in here. Okay, so after initializing this or having this constructor, what we are going to do is to define an iter method, right? So we can say def and two underscores and put it here. This is going to return the same iterator here. The next thing what we are going to do is define the next, and what we want to do on this next is to test if self.current, instead of equal, let's use greater than or equal to self.end. What do we want to do? We want to stop the iteration, right? Or else what we are going to do is to say self.current plus equal to 1 and return the current, let's say -1, for us to avoid going out of range, let's say -1 in here. So this is the implementation of an iterator class. You can see we have initialized this variable start and end in here, and then we put or initialize the current value with the start. And what we are going to do is this current is going to increment. So after incrementing it, it will contain the last value or the next value. So the next thing we are going to do, we are going to create an instance of our iterator here and say counter is assigned to counter, let's say 1 to 10 or 1 to 10 in here. And what we are going to do is we want, let's say, for example, print next counter. What we are doing is we are calling this next to print the next counter. Let's execute this code and have a look. You can see that even if we have put a range of 1, the start 1 and the ends at 10, but we are only printing a single value here using the print next counter here. So this means we are actually storing a single value in our memory. The next thing to do is let's print this using a for loop. Let's say for I in counter, let's print I. So what it is doing is it is keep calling the next function here to print all this value. It keeps calling the next function, next function, next function. Why? Because we have put it in a loop here. But under normal circumstances, it is good because it is only going to store a single value and print it as it is needed. By the time the value is requested, when the next function is called, this is when we are going to print that value, and it is going to leave our memory, and we are going to keep the next value into the memory. So this is what you need to know about iterators. We are going to talk about generators. A generator is a simple version of an iterator which removes a lot of boilerplate code, but it will work exactly as an iterator. So what are we going to do? We are going to define a function. Let's call it counter, and in this counter, what we are going to do, we declare a variable and initialize it. Use a while loop while n is less than 10. We want to yield, so it uses a yield keyword, and we add 1 to our variable. And after that, what we're going to do is to print the counter. If we execute this, we are going to see only 1, even if the value should run from 1 until 9. So the next thing we are going to do, we are going to put this also in a loop, and you can see that we automatically get the next function here without even implicitly defining it in our function or in any class. So we are going to initialize our count with counter and use a for loop and then print I here. We expect to get the same result as we are using an iterator. So this is what you need to know about generators and iterators. We are going to talk about exception handling in Python. So let's have a variable here. Let's say result, and assign it to an arithmetic operation where we are dividing by 0, and try to print the result here. Okay, so let's go ahead and execute this code. What you're going to see is an exception here. This red means that your code is broken. And if you try to use this code directly when you are doing a software or an application, if you don't handle exceptions well, your system is going to break. So this introduces us to what is called exception handling. You can see the message here, 0 division error, division by 0. Okay, so this is the exception which we have faced in the execution of this code. So I'm going to introduce to you. So the first thing you need to know is exception as a following syntax. Try, we have the try statement, we have the catch statement, or not catch, excuse me, the except statement. And after having the except statement, you can also have the else statement. And after having the else, you can have the finally statement. Finally, okay. So what does this do? They try to catch an exception, and this except throws that exception. The else statement is going to be executed if there is an exception. If there's no exception caught in the logic here, it is going to execute the statements under this else, and the finally is going to be executed anyway, even if there's an exception or not. So let's get started. Try here. What are we trying to do is to get the result of the arithmetic operation when we are dividing by 0. So after having this, we can simply print the result here. And what we're going to do at the same level with try, we're going to do except. We can see as a 0 division error here. And what we want to print if there is an error, we want to print there was an exception. Like in this case, we know what type of an exception is it, and we can simply customize our message. You cannot divide by 0 in this case, right? So divide spelling here. And after having this except, what I'm going to have is the else statement. What does this else do is to print, either print the result or print, let's give it a string here for clarity. Print in the else, meaning there is no exception in this case. And after that, we are going to have the finally. We are going to print this block is going to be printed, going to be always, let's say always executed, something like this. So if we execute this, we are going to see there was an exception. You cannot divide by 0, and you can see the else statement here was not executed since this statement only and the finally block were executed. Because we are trying to divide by 0, let's remove this 0 and put 1 here. You can see after dividing, we are getting in the else, meaning there's no exception in this case. So this is how a generic exception handling happens or is structured in Python. And this is just more generic, and these exceptions are predefined. So you can go ahead and look for generic exceptions in Python, and you can learn more about them. There are a lot of exceptions, some of which you faced when you are trying to run or writing your code. You have faced a lot of exceptions, and those exceptions needs proper handling for your software to be able to work as expected and to get the expected results instead of breaking that software. So the exception handling is a good part, or is the greater part of software engineering, where you can actually show the messages of what happened other than breaking your software. We are going to talk about custom exception handling. What we saw in the previous lecture was a more generic approach to handle exceptions. So let's say we want to define our own exceptions and when to throw them in our code. For instance, you can try to customize an exception. Let's say you are trying to run a query in the database and you faced an exception where you didn't find an object which you were looking for. You can customize the exception or throw in a custom exception. Or for instance, if you want to try to work with input or type conversion in Python, what you need to do is you need to customize your exceptions. So I'm going to show you how you can actually define a custom exception. So a custom exception is going to be declared or using a class, and let's say you want to put an invalid input error here, and this inherits from an exception. So this exception in brackets means that an invalid input error inherits from an exception, and we are going to look at OP concepts or object-oriented concepts in the next lectures. But here, what we want to illustrate is how you can actually work with these custom exceptions. So you can see an exception here, and the next thing which we are going to do is to define a constructor, right, that takes parameters which you want to work with. Like here, we just want a message here, and the next thing we want to set or to initialize that message with our value. And after that, this is a custom exception defined here, and we are going to have this super init, which is going to initialize our message or override our initialization with the custom message which you are going to provide. So the next thing which you want to do is to use this try except, right? So what you do want to do is to simply declare a variable and call it a number here, and we want to initialize it with a string. After initializing this value with a string, what we are going to do is we are going to check if not our number, if not number dot is numeric. If the number is not numeric, what do we want to do? We want to raise our exception with a custom message number, or the value must be an integer. Let's say the value here, the value must be an integer. And after raising this exception, what we are doing by raise, we are simply saying we want to call this class and initialize it with this value. As you saw how you initialize objects in the previous lecture in classes. So after that, if this is false, which means this is going to execute, and if this is false, which means you are going to execute the following statement, which I'm going to write. I can say number is assigned to int number. What I want to do is to convert this string into an integer. But if this condition is true, if we raise this exception, this means that there is no further execution which is going to take place in our code, and this is going to break and simply go straight to the except to print our exception if there's an exception. So we can put except here. Instead of value error, let's just use our custom custom invalid input error here and as error. What we are going to do next is to print the error or the error dot message in here. We are going to get the message inside this, and instead of using else, let me just leave it as it is, or let me use else to print the value of the number and print number here. And finally, we can simply print going out of exception handling block. Okay, so we have something like this. This is a custom exception, and this is how you can simply raise it or throw it so that it can be caught here with the except. And this is a custom variable which we have used to actually alias this long error here, which we have customly defined here. So let's go ahead and execute our code so that we can actually see how things are going. You can see the value must be an integer. Why? Because we are throwing this here. The value must be an integer because this is not numeric here. This is a string, and you can see we have printed that error here, so we raised it and then printed it here. So this is what happened. As you can see, going out of exception, this is the block which we have said it is going to be always executed. So this is what you need to know about exceptions and custom exceptions. You can go ahead and make some changes, define your own custom exceptions, try to handle them, and try to work around testing things. You should not be afraid to experiment things when you are a software developer. Why? Because this is going to open new insights for you on how you can handle or how best you can handle your code. We are going to talk about files. If you go to my folder structure here, where I have my Python files or the project, you can see that I have only .py files here. So I'm going to show you how you can work with text files. So firstly, let's declare a variable code file. What we want to create a file here with the given name in our code. So we can open and give a file name here, example.txt. This is a text file, and we want to open it in write mode. So this line is going to create this file if it doesn't exist, or if it exists, it is just going to write to it, overriding the contents of the text file. So let's write it, file dot write. What we want to write in the file is just this statement: hello, this is the first code in file handling, something like this. And since we opened our file here, we need to close our file. If you open your door, you need to close it. So here we open the file and we need to close it for us to be able to preserve the memory of our machines. So let's execute this code and have a look. You can see there's nothing in the console because we are not printing anything. So this is the first code of handling a file. We have just created a file. If we go to our folder structure, you can see we have example.txt, and if you double click it, you can have this line already written or appended to this file. So this is the first code. When you want to read a file, you simply do the same again. File called open, and you want to open the same file, example.txt. Not this time, not in writing mode but in reading mode. So you need to take care of this, or to read and understand how these keywords works. As you can see, we have R for reading, and if we want to read binary, we can put a B here, and there are so many more which you need to look by yourself so that you can understand. So I'm going to demonstrate the writing and the reading of a text file. After opening a file in reading mode, we are going to get the contents of this file and then print the contents. Finally, close the file. Let's execute this code. You can see we are getting this hello, this D is the first code in file handling. There was a typo inside our code there. So you can see this is how you can read the contents of a text file. So now we have read the contents of our text file, but we already have the another files in here, the .py file, the control flow file. So let's say we want to read this. You simply need to put the name here, control flow.py, and execute. So you need a file and its extension for you to be able to read it. So you can see the code which we wrote in the control flow here. We last wrote a while loop here. So this is what you need to know about file handling. I can also introduce you to using a with statement. This is going to control how long and how we handle the files. For instance, even if we are working with the statement, this keyword, we don't need to close the file, since it will automatically close when the with statement block ends. So we can say with open file, we want to open, let's say example.txt, and example.txt want to read it, and you can put an alias as file here. And what we are going to do is to read this file. So contents, as we did previously, we got file.read print contents. So there's no need to close this file because it will close automatically when this block ends. So let's execute and have a look. You can see we are still getting our output in the console. So this is how you can work with file or files. And you can also use exception handling when you are dealing with files. You need to just look at how you can apply exception handling. This is your assignment for you to be able to learn more and to be able to apply the concepts which you have learned. So let me know if you can make it, and if you don't make it, also let me know in the comment section, and I'll demonstrate to you how you can actually handle exceptions in files. But it's all the same with the exception handlings which we're doing before the file handling here. We are going to talk about asynchronous programming. So previously we were defining our functions, like let's start by importing time and define our function here called task and put a name. We are going to print something here, and we string format this, starting task and put a name here. After this, we want to sleep the thread for about 2 seconds or 3 seconds. Let's put 5 seconds here. And after sleeping the thread for 5 seconds, we want to print finish task and then the task name. We are going to call this function, and we are going to call it 2 times. So let's put task, and the name is task1 here, and call also this function with task2. So let's execute this code. You can see starting task1, and we wait for 5 seconds, then finish task1, and starting task2, wait for another 5 seconds, it will say finish task2. What this means is we are blocking the main thread when we are executing this code, which means the next line is going to wait for the previous line to complete the execution before its execution. So you can see we have printed this, and we head onto this line and waited for 5 seconds to print this line. And when we call this function, we call the function, and it gives us a wait of 5 seconds, executing only a single task, then moving on to the next. So asynchronous programming is going to introduce us to concurrent execution of these tasks. So we are going to demonstrate how you can use asynchronous programming to concurrently execute these 2 tasks, and this can improve the utilization of the main thread. This is called a blocking concept since we are blocking the main thread. So next I'm going to show you how you can concurrently run the tasks at the same time. So we need to share the thread using an asynchronous programming and the wait keywords. So we are going to import async IO. This is what we call non-blocking, which we are doing here. So to define a function, you use an async keyword and define the function, giving it a name and the parameter of a name in here. What we're going to do is to print starting, excuse me, we need to format this. I keep forgetting to format this string and put a name in here. After that, you need to sleep for some seconds. So use await keyword to sleep. Let's say we want to sleep for 5 seconds. The main thread will sleep for 5 seconds. And after that, we print finished in the task name. Then the next thing we want to do is to define another function that is going to implement the running of these two functions, or the core of two cores of the same function, to see if we can actually use or we actually run two different function cores in the main thread at the same time. So this is the function async dev main, which awaits and gather the tasks here. And after this, we are going to or async io.run main. What we want to do is to run this main thread. So what I'm going to do is, this is not the main thread, but this is now the main thread. So we have run the main thread, but it is going to be shared with these two tasks. Let's execute this code. You can see starting task 1 and starting task 2. So these two tasks started and they wait for 5 seconds and they executed also. So we are going to see in the console task 1 and task 2, and in the finish we also see task 1 and task 2. This means that the execution of this of the function calls, the first one and the second one, was done concurrently without waiting or the thread sleeping for 5 seconds. When the thread reached this await 5 seconds, it went on to execute the second core of the function, and to find out that it is waiting also for 5 seconds. So it printed this. Since it executes first, it printed the first function core, that it is complete, and then printed the second, it is complete also. So this is what we call concurrent programming or asynchronous programming in Python, as illustrated in this video. Let's talk of inheritance in this lecture. We have this diagram here. You can see we have a person, a student, and a teacher. Inheritance is simply the behavior of a class inheriting from its parent class. So we have a person and a student. We know that a student belongs to a person class and a teacher also belongs to a person class. So if we want to take the details, or if we want to have the details of a person, we know a person can be described by the details such as name, age, gender, and so on. So a student can also have those details, but when it comes to a student, the specific data of a student that tells us this is a student is a student number. And if we go to a teacher, specific data that tells us this is a teacher is a teacher's employee number or employee code. So instead of keeping those details in student, the name, age, gender, and some details in student class, we can simply have a centralized blueprint called person that can keep all the details of a student and a teacher. The common data between a student and a teacher can be kept in a class called person. And if we want to have specific data about a student or specific data about a teacher, we are going to have a new class or a child class called teacher, and keep the unique details of a teacher in that particular class. So this is what inheritance looks like. It takes the concept from the practical cases like human beings. If you are a parent, if you have your properties, your child is going to inherit all your properties, and including a family name and some details. So that's why you can see if someone have got a child, if they want to actually test this is my child, they can go for a DNA test, because there are some genes that are being passed from the parents to the child. So this is the concept of inheritance. We are going to look at it in practical in the next lecture. Inheritance in practice. Let's declare a class called person here. And after declaring this, let's initialize or have a constructor with a name. Can we simply need the name? No, let's add gender and age here. And let's initialize this name, gender, and age. After this, let's have an object or a method that is greetings or say hello. We are going to return a string that says, okay, let me format it, that says hello, name, and we can put a space from, let's say, from a parent class. Okay, so in the previous lecture, we were doing something like calling this class, and we were just saying person, uh, excuse me for the typos, person is assigned to person, and keeping these details. And we can simply print person here. When we want to print the person, we want to access this method, say hello. So if we execute, you can see hello from a parent class. So this is what we were doing, but to show how inheritance works, let's not do something like this. Let's remove this calling or instantiation of a class. We are going to create a new class here called student. And it is going to inherit from person. So if you see this inside brackets, when you create a new class, it means you are inheriting from a class named inside these brackets. And let's go ahead and say, instead of score, let's say student number. You can see as if nothing has changed here, but what I want to assure you is these are not going to be initialized inside this child class, these details which are defined here. But what we are going to call super for initialization, and we can put these details. Its name, gender, and age. And after having this, we can now assign our new variable here below here, so that you can see self.student number is assigned to student number. This is the constructor of our child class. So let's go ahead and declare another method and say display student. What we want to return is student. So format hello from student. And you can give a student number, and you can say the name is and self.name. You can see we are trying to access the name here, but it was not explicitly initialized in this child class, but it is initialized in this parent class. So we are going to declare or instantiate our student class now. What we want to pass in here is a name, age, and also we want to pass a student number as a string, something like this. And let's go ahead and print student. If we print student.display student, we are going to see the student details. You can see hello from student number 78866. The name is John. We have initialized it here, but these details are being passed from the parent class, as you can see that we have declared these students in a parent class, and we are not initializing them in here, but instead we are simply calling a constructor of a parent class. But by doing so, we are getting all the details. Let's go ahead and try to access this. You can see that the student class is going to inherit everything from this parent class, even the methods. So let's go ahead and print the student, and we want to say hello. You can see we also have access to say hello in here, and if we execute, we expect to see from hello John from parent class, and this is from a child class. So you can see that the methods of a parent class are also being visible in the child class. So this is what we call inheritance. If we want to declare more classes or objects, you can go ahead and, for example, declare a teacher here, a class called teacher that inherits from a person, and we want to have a teacher number inside here. What we are going to have another also is initialization of this. So we can call super and say dot. In it, we initialize name, gender, age, and after that we go ahead and initialize our teacher number. And if we create an instance of this, let's say define another method. Let's keep a line here. Define another method, display teacher self, and return something like this. If we create an instance of this, we are going to have a teacher instantiated with teacher, name male, gender male, age, let's say 45, and name is Peter, and student teacher number is 5. And if we print teacher.display teacher, we are going to get another message also. You can see hello from teacher number 5, the name is Peter, and the next is hello from student number 7 something, the name is John. Hello John from the parent, because we called the parent from a student class, not a teacher class. So this is how you can actually work with inheritance. Let's demonstrate how multiple inheritance works. So you can have your grandchildren, you can have your children inherit from you, your grandchildren inherit from your children, and your great grandchildren will inherit from your grandchildren also. So this is a hierarchy of inheritance. So this is what I'm going to show you in this lecture. So let's declare our class first, call it a person, and in this person want a name, and we set that name value, and we are going to define a method that say hello, for instance, and we are going to return a string, return let's format this, return we can say hello and the name here. So this is the first method, the parent method. We are going to declare a child class or child call. Let's say a person is an employee also, and inherits from person, and we are going to have the name and the salary of that person, and we are going to initialize by calling the super init to call this constructor method of the parent class. to initialize the name. And after that, we can set the salary to salary here. And after that, we just define another method here. Let's say hi, for instance, and return hi self name. And what also to show is the salary is, and the salary, the actual salary. Then after that, let's go ahead and declare a grandchildren of these classes. Let's say also a person is a student. That employee is a student. So instead of inheriting from the person, let's inherit from employee, for instance. And we are going to have the salary and name, salary, and also student ID. Okay, student ID. Then next, we are going to initialize these values, name and the salary, and we are going to initialize the student ID. After that, we want to say to define a method for greeting this student. Excuse me, let me remove this. And this simply takes nothing self and return self hello and welcome to, then give the student ID here. So this is what we call multiple inheritance. We have the parent here, the child class, and the grandchild that is inheriting from the child class. Here, another class that inherits from another child class is a grandchildren. So from the tree, you can draw it as a family, a parent, and a child, and a grandchild in that order. So let's go ahead and now show how this works. So we are going to create an instance of the first class, of a single class. We are going to create an instance of a single class, which is a student. We know that we are going to call all other methods from this. So we passed the salary in here, and let's also pass a student ID. Let's say 2453. You can see that it is giving this suggestion here, that is student ID. Let's go ahead and call, let's print, in fact, want to print firstly student dot, want to call the method in the parent, the say hello method in the parent here, and we want to print it say hello. And next we are going to print the student, instead of greeting, we are going to print say hi, which is from our employee class. And now we want to print the greeting from a student class here that inherits from an employee. You are going to see that it is going to work also. So we have hi John from the first class here, and we are going to see hi John, the salary is 5,000 from this is employee class. And we are going to see hello John, welcome to 245 blah blah blah. This is the student ID which we have provided, and it's coming from this class here. So this is how you can actually implement multiple inheritance. Encapsulation. Encapsulation is just the ability of a class to hide some data or restrict the access of some data which is defined in it. So let's define a class called account here, and we can have initialize the account with, let's move all the other details and say account name and balance here instead of account number, right? So we can initialize our account name, and the balance we can say self dot 2 underscores here and balance. If you see a variable initialized like this in a class with 2 underscores before the variable name it means that this variable is simply a private variable. It is only accessible within this class. So if you define another class and try to access this variable, you are not going to be able to access it, or even any instance of this class cannot directly access this variable. But there's need of a method that can work on this to access this variable and manipulate it. So let's go ahead and set an example. Let's say it's a deposit. We want to deposit a certain amount in the account. So we can say self, and this balance is going to be added, the amount which is being deposited, and return dot balance here. We can return nothing since we are just depositing here. Let's return the balance for clarity, self dot balance in here. And we can also have another method that acts upon this, which is withdrawal, and we want to check if the balance is greater than the amount being withdrawn. We can have this and return the balance after subtracting the amount being withdrawn. And the next move is when the balance is less, we want to return a string that says insufficient funds. Okay, after having this, we are going to have another method to just check the balance. We can say get balance. We return self dot balance here. So you can see we have our account here that have got account name and the balance, and the balance is being played with these three methods. So let's create an instance of this class and say account or active account, something like this. We have an account name. Let's put it John Doe here. So we have account name as John Doe and the balance as 5,000. The next move we are trying to let's try to print the active account. Active account, not deposit. But we want to first try to access this balance. If we say balance, you can see we don't have any balance option here. And if we leave it like this, it is going to complain. And what is it? Add field balance to the class account. You can see that it is complaining the field balance doesn't exist in this class account. But if you look here, you can see that we have it. But in here, we don't have it because it is made private. So we can't directly access this balance. So this is what we call encapsulation. This field now is hidden. It cannot be accessed or manipulated outside the class. But if you want to access it or manipulate it, you need to declare some methods that act upon that field in the same class and use those methods. For instance, if you want to print active account dot deposit and deposit 100, we have 1,000, remember, 5,000, remember, and if we print this, we are going to get a balance of 5,100 because we have deposited 100. And if we want to get the balance, we can print let's say 300, withdraw 300, and then get the balance. We can see that we got 5,100 by depositing 100, and if we subtract 300 from that balance, we are going to get 4,800. And the get balance have given us this amount. So we can modify the get balance and concatenate it with a string here. Let's format this and put it inside the string and say the balance is to differentiate between the depositing and withdrawals from the balance function. So this is it. You can see that we have this, and if we run, you can see that we have a different in the balances. You can see that this is the get balance method inside our function, inside our class. So this is what you need to know about uh, encapsulation. Let's talk about polymorphism. Polymorphism is simply the ability of an object to take any shape. So we are going to demonstrate it using a class. Let's declare a class called shape. And inside this class, we are going to define a function that calculates the area, and it returns a string. Hello, this is from the parent. Okay. And after this, let's also declare a different class that is going to inherit from this. Let's call it a rectangle that inherits from shape, and we are going to initialize with the width and the height for the rectangle, and set the width and the height, initialize them here. The next thing we are going to do is to define the area, and we are going to return self.width and the height. What are we doing here? We are overriding this function inside this, or this method inside the shape parent class. We are overriding it in the child class. You have seen that previously when we were talking about inheritance, we would prefer to define a method with a different name here and here, so that we demonstrated how you can call the method from the parent. But now we want to call the same method with the same name from the parent, but getting different behaviors. So that's polymorphism, to get a different behavior from a same uh, method name, right? Like this, you can see we are getting a different behavior. Here it's returning a string, and on this line it is returning a calculation. Maybe it's going to be a double or a decimal or a float value, or it's going to return an integer. So let's go ahead and create this instance or an object of a rectangle here, rectangle, and pass the parameter. Let's put the height to 7. And if we want to print the value, we can simply use print rectangle.area. So now we are calling this object, but it is going to override, this method is going to override this method. So if we run it, we expect to get 35, of course, because we have overridden this first method. So we can also demonstrate this by declaring another the class here called shape, a circle inheriting from shape, and we want the radius. Set that radius here, and we are going to define another method of area also that returns the radius. So it's pi is 3.14 multiplied by radius, like multiplied by radius squared. So this is what is going to be retained. So we want to show how different behaviors are going to be gotten from these different classes and their methods. So let's go ahead and create a rectangle first that takes 2 parameters, and let's get an area. Let's print the area of the rectangle, and let's go ahead also and get an object of a circle here, and put 5. Let's put 2 as radius, and print the circle dot area here. Let's also print the parent class method output. So let's call a shape, assign it to shape here, and we can call shape dot. Let's print it. Let's just call it because it is already a print statement inside, or it's returning all. So let's print it here. Print shape dot area. We are going to see the following output. Here, hello from the parent, you can see it's the same method name we have used in 3 different classes. And in these 3 different classes, the same method has got different behaviors. So this is a first behavior that returns a string. This is returning an integer. And this one is returning a float. So this is how you can actually demonstrate polymorphism. Thank you for following along on this course. Please don't forget to like the video and share the video with others so that they can learn what you have learned. And in this video, I tried to equip you with the basics and the advanced concepts in Python so that you can advance your career. So in the future, we are going to demonstrate how you can develop web applications using a Django framework, a Python framework for developing web applications. So I'm going to start from the basics up until to the advanced concepts of Django so that you can become a complete Python developer. And for you to not miss this, you need to subscribe to this channel and make sure you also share with others on what we are going to learn next. Thank you.